sum and difference identities. This will be day one. We'll do sine and cosine today, and we'll leave tangent for another day. That I have in the oval there is pretty much the formula for doing that. And this is basically, what if you had to find some angles that are not on the unit circle, but you had to find the exact answer and had to do it by hand? I think we can all agree that if you look at example 1, if all I had to do was that and get the decimal, we could type that into a calculator and pretty much be done already. But what if they want that answer exact? Well, that you can't do on a calculator. Now, like I just said, we know sine and cosine. If you take sine and cosine of an angle, it has to be less than 1. And just to see if you got some ideas going, do you agree 15 degrees, probably somewhere in there? Would you think that this cosine value is going to be close to 1? So is it going to be bigger, or is it going to be smaller, like closer to 0? If this is the value that we're at. Again, cosine's the x value. So this will be closer to 1 or closer to 0 if you actually did this one? Quite a bit closer to 1, right? So if I got an answer of like 0.1 for this, probably not right. Okay. 0.9, well, that could be right. 0.8, that could be right. But I kind of want you to think of various other things like that. Now, this little formula, they give you an x and they give you a y. All that is two completely separate angles. In this particular example, it's going to be 30 and 45. Are going to be x and y, depending on it. But what I have to do is I have to make sure I do the same problem. So how can you use 45 and 30? How can you use those two numbers to actually get it to, say, 15? 45 minus 30, do you agree with that? That would be 15? So that's saying the same thing as taking, now can I write this in the other order, or does it have to be in the 45 minus 30? Does it have to be that way? Yeah, you can't put 30 minus 45 because that would be negative 15. So really the two that I have written here are saying the same thing. You with me on that? And notice that I know those two. Are those the only two values that we could have used to get 15? No, we could have used a ton of them. I just told you, let's use these two. We'll see what happens. Now, up here in the formula, you notice, I'm going to get some of this out of there. What do you notice about that symbol compared to that one? It's been flipped. What that means is if you say plus here, it matches up with minus over there. And if you say minus here, it matches up with plus there. Okay. And I'm going to kind of consider like this is x and that's y for our purposes, correct? Because x came first. Once we do one of these, you'll get it. Unless you might get it already. So here it basically says take cosine of x. Do you see how x is the first angle? So let's go ahead and take cosine of the first angle, which is 45 degrees is my first angle there, right? And then it says to take it times cosine of y, and I would consider y being the second one, right? And y here is 30. Did I put negative 30 degrees in there? No, I just put 30 degrees. The reason I asked about the negative is some people look at that negative right there and they think, oh, we got to put negative 30 in there. No. Now, who thinks they can tell me what to write next? And if you get this part, you got probably the hardest part of cosine's little formula. I have a minus right here, and a minus turns into a plus. So plus, and then it says take sine of the first one. So sine of 45 degrees, and sine of the second one. So sine of 30 degrees. So what we've done is we've changed a cosine of 15 degrees, because that is not one of them that you've memorized, or hopefully memorized on your unit circle. This is one that we had to get to other ways. Now, hopefully, you're getting pretty good at these. For example, what is cosine at 45 degrees exactly? Not decimal, not any of that, exactly. Yeah, that's sitting right here, right? So this is square root of 2 over 2 and square root of 2. Which of those two should I be looking at? The first one or the second one if I'm asking for cosine? Yeah, the first one. So square root of 2 over 2 times cosine at 30. We're going to say this is 30 degrees now. What's the ordered pair right there at 30 degrees? Square root of 3 over 2 comma 1/2, yep. So which of those two values should I be looking at if I'm doing cosine of 30 degrees? Square root of 3 over 2, very good. All I'm doing now is I'm replacing the values that the formula told me to look at. And what should I write next? Well, the plus. How about sine of 45? Is that something we should know? Yeah, we should know that. It's sitting right there, square root of 2 over 2, right? Times, how about sine at 30? Is that something we should know? Yeah, it is. Yeah. The very nice thing about all the ones on the unit circle, you know, is that the bottom is always 2, right, on the unit circle, on those ones that we're looking at here. So that's nice. Any questions of how we got to where we are so far? Yes? Meaning if this was a plus sign here? Or if there was a plus sign in here, this would be minus down here. Yep, because the plus turns into minus. Yep. Mm-hmm. And I'll give you a little memory device in a little bit to remember that works. Well, here's a plus sign, right? So can I do anything to that? Can I multiply the square root of 2 and the square root of 3? Can you put that together? What does that become? Yep, square root of 6. I'll write it a little higher because I see some of you in the back there kind of starting to lean there. Now, this is multiplying fractions. What do you do with the 2's? It's 2 and 2. Do you multiply it or do you leave it? No, that's adding when you're adding. So right here, this 2 times 2, I can actually do that. So it's over 4. What's nice on a lot of these you will get common denominators almost by mistake. So I'll do that in green and I'll do this one in red. Why am I looking at them separately? Because there's a plus sign right there, okay? Same thing over there. Can I take the square root of 2 that's on top times the 1 that's on top? Well, yeah, that's easy. That's just square root of 2. Here's the plus sign over 4. You see what I mean? You almost get a common denominator without even trying in this problem. And now that you have your common denominator, you can write it as, and that's the best you can do. Because does the square root of 6 break down so that I can actually add it to the square root of 2? No, it doesn't. Okay, not nicely. I could make it the square root of 3 and the square root of 2, but that doesn't go anywhere, all right? And so that doesn't help. Now, I want you to, right now, if you have that calculator, please go ahead and find that decimal for it, being the square root of 6 plus the square root of 2, and then divide it by 4. Find that decimal, and then take cosine of 15, make sure you're in degree mode, and see if you get the same decimal. Let's go ahead and try that right now. According to some of my calculations here, it should be right around 0.9659, somewhere in that range. Does that follow what we expected to have happen when we looked at it earlier? Cosine of 15, you told me to be closer to 1, and I agree. So did that decimal that I circled in red come out to be the same thing as cosine of 15 degrees? Exact same thing. So that's cosine's formula. How do you know if you use cosine's formula or sine's formula? Well, you look at the problem, and it said cosine of 15, so I used cosine's formula. Okay? Again, I didn't have to use 30 and 45. I decided to use those. Anything that would have gotten me to 15 would have been fine. I promised you a memory device. I remember that in sine, the sign stays the same. Which means in cosine it switches. So in sine, the sign stays the same. If it's minus here, it's minus there. If it's plus there, it's plus there. Okay? So we got 75 degrees here. What do you think? Closer to 1 or closer to 0? Closer to 1 again, yeah. So here we go. How do we know we're going to use sine? Because it says sine right there. And can you use 30 and 45 and actually get to 75? Yeah, how do you do that, though? You have to. Yeah, and if you're adding, it doesn't matter which order, right? So you get to kind of choose whichever one you're more comfortable with. And so we know sine of 75 degrees equals sine of, well, which one do you want to put first? You tell me. 30? Okay, just the order they are. That's fine. And again, because it is plus, really doesn't make a difference. And if you like, I don't know if this helped last time, but kind of marking that as x and that as y, maybe that helped some of you, showing you that one angle and the other. Now this one is a little different. You may notice on this one you just did cosine and cosine and then sine and sine. Where this one you do sine and cosine and then cosine and sine. So it says sine of x. So sine of, well, what's my first one is? 30 times cosine of y, which is 45. And so based on what I just showed you or just told you, what should be the next thing that I should write down? A plus. And then cosine of 30. And now did I really do, I took sine of both values, right? And I am going to take cosine of both values. Agreed? What's that? So let's just get these two in there again. It's square root of 2 over 2, and square root of 2, and then square root of 3 over 2 and 1/2. That's a 3. Sorry about that. How about sine at 30? What have we got? 1/2 times cosine at 45 plus times so we still got that plus that kind of has to stay in the middle, right? And so this one, this first term, these first two terms gives me what? Square root of 2 over 4. And then these two, that's a horrible 2. Square root of 6 over 4. And I think I heard somebody make the comment I was hoping for. We just got the same answer. Should we have gotten the same answer? Exactly. Look at the two. This one is saying 75 degrees and look at the y value. The first one was saying 15 degrees and look at the x value. They're both 15 degrees away from that axis, correct? So should they have come out to the same value? I was almost hoping somebody would say it before we went through the whole problem. That would have been impressive. But you're getting better. You at least noticed that was the same thing, and you could tell me that why they were the same thing in the end. Okay?